Yeah, hello. You're welcome to Loveschool Academy, and we want to take a look at BECE 2019 Integrated Science, specifically the objectives we want to revise, especially in these times whilst we are at home and then schools have been shut down. So let's. It's very easy for you to follow with our content because we have video pictures on the slide. Each slide will help you to better understand whatever question is being asked, or whatever concept that is being that you are being examined on. So the first one, steel is an alloy of what? Iron, and the answer is carbon. Now if you take a closer look at the picture, this picture shows you what you call steel rod. However, mistakenly, we, or a lot of us, call that iron rods. They are not iron rods as it were. It is rather steel rod because it is made up of iron and carbon. It's not only iron, it's made up of iron and carbon, so they are known as what? Steel rods. The second thing is that second question, an atom that has lost one or more electrons is called, so it's called an ion. Now you realize that a neutral atom is one that has not lost any electron, it has not gained any electron, it's just the way it is. However, if you look at so just look at the diagram beneath the question, just on the left side, you realize that when a neutral atom loses electron, it becomes a cation. Cation is an ion, so cation, the ion there shows that it's an ion, cation. Then when it also gains electron, it becomes an anion. So I hope you get that. So whenever an atom loses or gains electrons, it becomes an ion. As to whether it's a cation or anion would depend on whether it lost electrons or it gained electrons. So over here you realize that when an atom loses electrons, it becomes a cation. Cation, that's with a positive charge, but when it gains electrons, it becomes an anion with a negative charge. Question number 3. In all machines, the efficiency is what? Always 100%. B, less than 100%, more than 100%, always 0%. So that's, we know the answer is so less than 100%. In other words, there's no machine that works. There's no machine that works effectively 100%. That's what the question is saying. If you hear or if you see anywhere in any text when they say that the efficiency of a machine is not is less than 100%, all that they are saying is that there's no machine in this world which works perfectly 100%. This is what it means. Look at the diagram over here. So the diagram, you realize that we have the E input, the E there for energy input. That's the energy you use in what? In that the energy you apply on a machine for the machine to perform a certain task for you. So you would realize that some of the energy, so you look at the machine, beneath the machine, some of the energy goes waste. That's why we have the E waste, and it's normally as what? As heat. For example, if you take a laptop, it's a machine. The efficiency of a laptop is also not 100%. It's less than that because some of the energy from the electricity goes to the laptop, fine, it will work alright, but some of them will go out as heat. So that's what we are saying. Although quite a proportion of it will be used to do the work needed, the useful work. However, some amount of the energy is going to be lost as heat. So we say that in all machines the efficiency is always it's less than 100%. It's not always, it's less than 100%. Then question 4, in electronic circuit, LEDs, what you call light emitting diodes, that's LED, are used to indicate the absence or presence of what? Of electric current. Basically what it means is that if you have a LED in a circuit, if there's electric current passing through, it will give off light. It emits light. It's as simple as that. So with different colors and all that. But if there is no electric current flowing through a circuit, it wouldn't give off its light, so it will tell you that there is no what electricity or electric. Question 5: which of the following statements about the scientific method is or are true? It provides I, logical procedure for arriving at knowledge. I, knowledge that can be verified. I, knowledge that can never be changed. So if you look at the diagram over there, it's just a summary of the scientific method. So first, you have what's called observation. Observation is where the problem is being identified. Then you move on to where we call the questioning. It's also still part of the identifying the problem. Then we go to what you call hypothesis. So hypothesis is when you suggest an explanation or a possible answer to the question or to the problem you have observed or to the problem you have identified. However, it is not certain that that explanation is the guaranteed reason why that problem exists. It's just a suggested explanation. So it means that from there you experiment to prove whether your hypothesis, that's your suggested explanation, is true or it isn't true, depending on the result you are going to get from your experiment. So this is basically what the scientific method is all about. So you will realize that the scientific method, it provides a certain procedure. If you really understand what you realize that it provides a certain step-by-step approach or procedure which helps scientists to arrive at knowledge or arrive at a discovery, as it were. Without the scientific method, scientists will just be doing anything anyhow. They will just be doing things according to their own ways. But because the scientific method is there, they are all forced to use that same approach. So that's one benefit of the scientific method, or one important, the fact that it provides a logical procedure, meaning a procedure that makes sense for you to be able to arrive at a discovery or at a solution to a problem. Now the next one is knowledge that can be verified. In other words, knowledge that can be tested. And you realize that this time method will do so because all of us are using this approach. So if someone comes out and then tells us that he has discovered this, or he has realized that this thing does this thing, all we need to do is that we also use the same scientific method that he used. Then we confirm that what this scientist said or discovered is true. So scientific method is very, very important. In this case, it will help scientists all over the world to verify or discoveries, to confirm or prove discoveries by other scientists. So that is why we are saying that I and then I are the answers. It does not provide no, that can never be. That's false. Knowledge is always changing whenever there is a new discovery. Not just. Question 6: which of the following substances is a compound? So hydrogen, nitrogen, oxygen, all these are elements. So you would realize that it is water. Why? That's a picture of water, the compound water there. You realize that it consists of hydrogen and oxygen. And any substance is made up of what? Of two or more elements that are chemically combined is a compound. So this is what makes water a compound. Question 7: which of the following sources of energy is or are renewable? So basically, renewable sources of energy don't get finished, just like the word itself. They are renewed, sort of renewed, so they don't get finished. They are always new, as it were, don't get finished. So you have solar, that's from the sun, crude oil, petrol, and the rest, kerosene, and the rest. And then you have wind. So it's obvious. Solar, the sun doesn't finish, the sun will not finish. Then the wind, how can the wind finish? So I and then I. Crude oil, petrol, that's oil, coal. They can get exhausted. I think there's this country in the Middle East where they realize that their oil would one day finish, so they have used all their monies or their resources they have gotten from their oil deposit to invest into their tourism sector, and then they are making a lot of gains from it. It was actually something they planned so that in case the oil gets finished completely, they will have their tourism will now sort of be a main of income for the country. I'm sure most of you know that country. The pressure, that's question 8. The pressure in fluids would do what? Would it decrease with that? Would it increase with that? Would it act upwards at any point? Does it act different in all directions? So the diagram here just gives us the answer. So you realize that the pressure increases as you go deep down the water. You see, when you are at the top part of the water, that's the first one, you realize that the water flows with some small force. The pressure is not that much, so the water doesn't travel a longer distance. It's just close to the container. But when you go, as you go deep, you realize that the water now travels at a greater distance from the container. Why? Because the pressure has increased. That is why there's enough force pushing the water out to that great distance. So obviously pressure increases with depth, or how deep the particular location is. Question: which of the following chemical equations is balanced? So for a chemical equation to be balanced, you would have to have the same number of atoms of a particular element being on the left and also be on the right side of the equation. So if you take A for example, A, you have 2 nitrogen atoms on the left side of the equation. That's where the reactant are. But on the right side of the equation, where the product are, the nitrogen is just 1, so obviously it's not balanced. Now when you come to B, you realize that B, there's 2 nitrogen atoms on the left, but just 1 nitrogen atom on the right side of the equation. So that is also wrong. But when you come to C, 2 nitrogen atoms on the left, 2 nitrogen atoms on the right. Then you come to hydrogen. Take note, it's not just nitrogen. The A and B, because the nitrogen was not balanced, there was no need for us to even check the hydrogen. So for hydrogen it is 6 here. Take note, so the 3H2 actually means that you have H2, H2, H2. So 3H2. So that's 6 hydrogen in all. Now if you look at the right side of the equation too, you realize that the 2 is in front of the NH3, so meaning that the 2 is affecting both the nitrogen and the hydrogen, and the hydrogen already has some small 3 down there, so it means that you would have to multiply the 2 by the 3 down there to get the actual number of hydrogen. So hydrogen is 6 over there, so this makes the hydrogen to be 6 on the left, 6 on the right. Nitrogen is also 2 on the left, 2 on the right, so obviously that's the balanced equation. Question number 10. Lime juice tastes sour because it is what? Acidic. That's one property of acid. That's how to identify acids. Most often, substances which taste sour are acidic in nature. Like vinegar, for instance, acidic, ethanoic acid, so it tastes very sour. That's what is used in salad dressing and all. Number 11. A metal block has a mass of 1 kilogram. What is the volume of the block if the density is 10 kilogram per meter cube? So over here this is formula work. So the formula for density, take note, density, the symbol, that's a symbol there, it's not P, it's called rho. It looks like P, but it's not P, it's actually a Greek, one of those Greek letters. So rho is equal to mass over volume. Now in this case you have been given the mass, you have been given density, so you are looking for what? For volume. Now if you look at a triangle, this triangle normally is used to help to solve questions that involve the use of formula. So what you do is that whatever you are finding for in the question, you just cover it. So for instance, you have to find for volume, so you cover the V. If you cover the V side, you will be left with M and then the P, the rho, or the density. So meaning the formula for volume is mass over what? Density. So it's just a way of helping you to remember how. So volume is equal to mass over density. Mass is 1 kilogram, density is 10 kilograms, so that's 1 over 10. And from our basic mathematics, you know 2 over 10 is 0.2, 3 over 10 0.3, 1 over 10 is also, so it will also be 0.1. So it's 0.1 meter cube, or it's the same as 0 meter cube. And question 12: it is easier to move a heavy load with a crowbar when the, so if you have a crowbar, it would be very easy for you to lift up a load, or maybe like sort of be able to remove a nail from that has been stuck inside the wood. When what? When the effort distance is longer than the load distance. In other words, when the crowbar is a bit longer. So if you look at the diagram here, you see the distance from the fulcrum, what you call the pivot, where the green triangular object is, from that side to where the effort is on the left, that distance is the effort distance. So you see that it's greater, it's long, as compared to the load distance, which is on the other side. So this makes lifting the load very easy. Why? Because you require small force. So all that we are seeing, so whenever the effort distance is longer than the load distance, it makes the work easy, because you just have to apply a small force. Then question 13: Benedict's solution was added to a mixture in a test tube and it turned brick red when heated. The mixture is likely to contain what? Glucose. This is one of the tests that is performed to test for the presence of glucose in a substance. Benedict's solution is actually blue in color. That's the first one in the diagram. Benedict's solution is the first one. That's the natural color of it. So you realize that down there they've written said none, meaning there is no. When you have a sample and then you introduce the Benedict solution to it, you put few drops of it inside it, and then there is no sugar in it. It will still retain its original color. It will not change the color. But if there are traces of sugar or glucose in there, it will start becoming green like that. But if there is higher, it will start changing color. But if there is a lot high amount of glucose there, then it becomes what we call brick red PPT. So normally we use the brick red PPT to show for the presence of glucose in a substance. So for example, if you take your urine and then you introduce the Benedict solution to it, and then it turns brick red, obviously means there's a lot of glucose inside your urine. But if it still retains its color, that's the blue color, it means that there is no glucose in your urine. In question 14, chlorine gas is an example of what? So it's an example of a molecule. A molecule in the sense that naturally chlorine doesn't exist as a single atom. It is always found bonded in pair. So when atoms are bonded together or they form groups, we call them molecules. Then 15, which of the following statements about a force are correct? Of course, force, the unit for measuring force is Newton, so the first one is correct. It is measured in Newton. No, it cannot be correct. Can start a motion? Of course, if there is a ball lying on a table, if you apply a force to it to start moving, so obviously a force can start the motion of an object that was stationary. You could also change the direction of your moving here. So if an object is moving in a particular direction, you could apply force to it and then change its direction. Then yeah, so it means it's 1, 3 and then 4. So you see the picture over there, the children playing with a kite. It can change the direction in which the kite is moving using the force, the pull from the boy himself. Then question 16, kerosene is able to reach the other end of a wick by what? Its capillarity, or capillary action. So a wick, that's a wick in the diagram. Wick is normally used in lamps. So you see those small lamps over there. The wick is inside the container of the vessel. then normally you have kerosene or some fuel around it. The fuel will penetrate or go through the wick by capillarity, and then it will give off the fire outside like that. It's just the way that the old lantern lamp works. So capillarity is the rise and then the fall of liquid in narrow tubes. So the wick would act as a narrow tube where the kerosene would rise through. So we call that capillarity or capillaria. Question 7: which of the following processes used to separate insoluble solid from liquids? That is for filtration. So for example, in the example here, you have mixture of water and sand. So the sand is insoluble, and normally if you have an insoluble substance not dissolve but inside a liquid substance, you just have to use filtration. So you put a filter paper there, and then you just, because the insoluble does not dissolve in the liquid, when you use the filter, it will just separate like that. Question 8: which of the following chemical compounds is used in removing hardness in water? So that's sodium carbonate. So sodium carbonate, a whitish substance, just added to the water, then it will react with the minerals inside the water, which is causing the hardness in the water. Hardness in water means that there are presence of certain ions which makes the water to behave in a certain way. It will make the water to not to lather with soap easily. So it's difficult washing with hard water. Hard water does not lather with soap easily. It's difficult because of the presence of some ions like calcium ions and other magnesium ions and the rest. Now you would have to remove it depending on what you want to use the water for. As I say, if you want to use that water for washing, it makes washing difficult because you don't lather easily with soap. So you have to remove it, and in removing it, we can use some of these substances, the sodium carbonate, which will react with the minerals inside, and then it can be separated out of the water. Then question 19: when a thermometer is put in hot water, the mercury level rises because the mercury increases in what? Not in density, not in mass, but the volume. So it rises, so it occupies more space. Volume, too, as we know, is the amount of space occupied by matter. Question for this section: the work done when a force moves a body through a distance of 12 meters is 720 joules. The force applied is what? So this one, you just use the same method I said. So you have a W on top, F and S down. So you need force, so you cover the force. You have W up, S down, meaning you would have to divide work done by what? The distance. So work done is 720, and then the distance is 12. So it means that we have to look at 720 divided by 12, and the answer is 60. So the answer is D, 60 newtons. Alright, thank you very much. Continue in our next